Welcome to Recovering Evangelicals, a podcast for people who were once very comfortable in their Christian faith until the 21st century intruded and made it very hard to keep on believing. I'm your host, Luke Jansen.
And I'm Scott Dyer.
This podcast has always been about asking tough questions about our Christian faith, particularly the evangelical expression of Christian faith. Of course, one common discussion topic is going to be creationism in all its forms and flavors. 4 years ago, when this podcast was still gaining momentum, we did a couple episodes that are quite overlapping in their content. One on intelligent design, that was episode number 21, and the other on fine tuning in episode number 22. These two ideas are foundational for the faith of many Christians. I don't mean foundational as in like a tenet of their faith, a dogma, like the Trinity or the virgin birth or inspiration of Scripture, but rather a reason, a defense, or a support of their Christian faith. Kind of more like scientific evidence that they see as supporting Noah's flood or young earth creation, the Shroud of Turin supporting the story of Christ's crucifixion, events that they see as answers to prayers they've made. These are foundations for the rationale of their faith, not so much the content of their faith. Both these ideas, fine-tuning and intelligent design, both boil down to the idea that all you have to do is look at nature and you'll undoubtedly be convinced that there is a creator. Of course, the Apostle Paul says as much in the first chapter of Romans, where he writes, "Since the creation of the world, his invisible attributes, his eternal power and divine nature have been clearly seen, being understood by what has been made." And again, that's the Apostle Paul. The psalmist wrote a much longer version of the same idea in a long psalm, Psalm 19. I'm not going to read it all, but it begins with, "The heavens declare the glory of God, the skies proclaim the work of his hands. Day after day they pour forth speech, night after night they reveal knowledge." My co-host and I, Boyd Blundell at that time, we were proud of what we'd produced in those two episodes 4 years ago. But those were mostly our own ideas and perspectives. We didn't really bring hardcore experts on those two topics. So last year we took another look at intelligent design. In fact, we did a whole mini-series on it. But this time we brought in the big guns. Michael Behe has long been one of the biggest names in the world of intelligent design, with a PhD in biology, in genetics, and decades of lab bench experience to go behind that name. And he explained why he's such a passionate defender of intelligent design and backed that up with all kinds of evidence and scientific claims. The problem is many people aren't able to fact-check or properly critique those claims. So we also brought in 3 geneticists who work in the very specific scientific area that Michael Behe bases most of his talking points on. Experts in the nitty-gritty details of the bacterial flagellum. 3 experts with all kinds of graduate degrees and decades of lab bench experience in that area. And they gave us a picture that looked completely different from the one that Michael gave us.
Yeah, those were really interesting discussions, to say the least. And I think it was very, just to your point, just what you just said, that the problem is that if you only read a fellow like Behe and you're a guy like me who doesn't have a background in biology, and I'm sure many others who, because we're reading the book out of a desire to defend our faith, but we're not equipped with, we can't fact check. We can't read it in a sense intelligently. We just have to go by what is being said. And if you stop there, then you're not going to get a complete picture. So I think, having some other experts on and hearing that other side was extremely helpful.
And do you remember once you heard the picture that they painted of how the flagellum came to be? I found it to be such a beautiful picture, just the whole idea of how one nanomachine morphed into another, which morphed into another, which morphed into another.
Yeah.
It was a really cool and interesting picture.
It is. It's fascinating, yeah.
Now, some might say that Michael Behe in the story of the bacterial flagellum wasn't the best test of the intelligent design hypothesis. So we got in another heavy hitter, Jonathan McClatchy, a newer member in the leadership of that movement, one who's making quite a name for himself in the world of Christian apologetics. He also has graduate degrees in biology, although not the lab bench experience to go with it. And he also made some big claims, often arguments that involve lots of tens with lots of zeros behind them. And he referred to the long-term evolution experiment, a group of scientists who are growing bacteria through thousands and thousands of generations looking for evidence of evolution right in front of their eyes. And Jonathan McClatchy, looking over their shoulders from a distance, concluded that the group only found evidence of breaking genes and biological dysfunction. And he often heightened his rhetoric with words like catastrophic and disastrous failures. So we brought in one of the members of that very group of scientists, one of the people who are actually conducting the long-term evolution experiments. And he gave us a very intriguing and compelling picture of an absolutely beautiful sequence of genetic changes that illustrates so much about how evolution works. If you're a nerd for Christian apologetics and the intelligent design answer to the question of evolution, then I recommend you go back to episodes number 130 to 140. Yes, you heard it right, 11 episodes, including several of the most scientific episodes we've ever produced. We'll have links in the show notes. Scott, I'm sure you remember that. What did you think after it was all said and done?
Oh, yeah, I remember for sure. It was many fascinating discussions and, somewhat challenging to follow. There was a fair bit of heavy science in there, but nonetheless, some of the analogies that you used to explain some of the basics of genetics and so on was really, really helpful. And yeah, for myself, I've for years been following the ID movement and been kind of intrigued by it. I've never bought into it completely, but I've been intrigued by it and kind of thought, well, maybe there's something here. But after these episodes, I really have more or less settled in my own mind that, first of all, I don't think it's a scientific approach. I think that's one of the things that came out.
Right.
And it came out in that Kitzmiller trial as well. Even the judge, who was a Christian, said, there's no science here.
Right. Yeah.
And so that's one aspect of it. But also the science that they do try to argue for is not particularly solid, as we saw from a number of experts that we talked to. So yeah, it definitely changed my viewpoint on the whole thing.
Right, and it did for me as well. Although part of what we did in those 11 episodes, I've been thinking that way for 10 years. But having heard from Michael Behe and Jonathan McClatchy and how their explanations, they sound at first very good, but then when you hear from people who actually work in those areas, a lot of what they said just fell apart, and that was a real eye-opener for me.
Yeah.
But getting back to what I have already been thinking for 10 years, I'm very much not a proponent of intelligent design because a lot of it having to do with the whole, what I've referred to as clumsy design or even malicious design. I've said in episodes many times, if you're going to attribute to a designer all the beautiful and wonderful aspects of biology, then you also have to attribute to that designer the examples of design which in some cases don't look very good at all, and in some cases they look downright evil and sadistic. And we've often given these examples. The two in particular that I always use as talking points is the design of childbirth in humans, which so often results in the horrible deaths of so many mothers and children. It doesn't have to be that way. Or the design of our airway and esophagus, which ends up with people choking on a piece of steak or drowning at the beach. Again, I just don't think it needed to be designed that way. I've never come across an explanation that makes sense to me why it had to be that way. And then you have to ask, why would the designer do it that way if there was a designer carefully crafting us from the ground up?
Yeah, that's certainly a significant issue. For me personally, the bigger issue is more the God of the gaps issue and the fact that what kind of a picture does that paint of God as a designer, that basically you've got this kind of random process chugging along and then every once in a while it gets stuck. And so God kind of intervenes and does some sort of miracle, I guess, to create the flagellum out of, de novo, and you have this going on all through the process. That just, to me, it does not paint the kind of picture of a creator, or certainly of the Christian God, that it's more, I don't know, it's kind of like a mad scientist tinkering and then letting things go to a certain point and then saying, well, that's not going to kind of get me there. So then they go and they meddle around with it a bit and then it starts up again. That's my bigger issue with it. Yeah.
Yeah. And we're certainly not going to repeat what we did in those episodes. Go to the show notes and you'll find the links to those episodes. But I know the one response that ID people will often throw out at this point in a conversation like this is they'll say, well, God had to work within design constraints. And they don't explain what they mean by design constraints. They just throw out this explanation that just can't be defended. It's easy to say that God had to work within the design constraints. There were things that God couldn't do in the design, but then you need to explain what you mean by that.
Yeah.
So that's intelligent design. It's one of the things that gives people a reason, a rationale, a defense for their Christian faith. But now there's this other very related aspect of fine-tuning. And to be honest, I have for a long time found that idea of fine-tuning to be somewhat compelling. I've mentioned that for me at least, the biggest argument against the existence of God is all the evil in the world, but the most compelling argument in favor of the existence of God is the fine-tuning of the universe. But it's not just me who thinks there's some merit to this idea. In 3 weeks, we'll be talking to an atheist who finds evidence of fine-tuning of the universe. And even a preeminent scientist and atheist like Sir Fred Hoyle has said some very provocative things about fine-tuning. Some listeners might not know much about Fred. He was a world-leading astronomer and astrophysicist, the guy who came up with the idea of how stars produce all the larger atoms in the universe, smashing hydrogen and helium together in the furnaces of the stars to produce bigger atoms like carbon and oxygen and nitrogen, sulfur, even all the way up to metals like iron and uranium. Sir Fred Hoyle was an extremely smart guy, but he was by no means a theist. He rejected the idea of the Big Bang when it was first proposed, and I've been told that was because it just gave too much ammunition to creationists, because it confirmed that the universe had a beginning, and he preferred to think that the universe had always just existed. In a few weeks, though, we're going to hear that possibly creationists and Christian apologists might have put a bit too much spin on that story. Stay tuned on that. But despite all that, he notoriously said something that sounds an awful lot like fine-tuning. I found many quotes from him at many of the highest prestigious scientific meetings that astrophysicists gather at, and in some of his papers published in very prestigious scientific journals as well, where he's talking about the molecular structure of carbon and oxygen. And he repeatedly mentions how it looks like these atoms were designed, carefully put together by some higher intellect. And here's one quote in one of the most prestigious scientific journals, the Annual Review of Astronomy and Astrophysics. In that journal, he wrote, "A common sense interpretation of the facts suggests that a superintellect has monkeyed with the physics as well as the chemistry and biology, and there are no blind forces worth speaking about in nature." He was talking about the carbon atom, and it just looked monkeyed with.
Yeah.
Here's another quote from the journal Engineering and Science. "Some supercalculating intellect must have designed the properties of the carbon atom, otherwise the chance of my finding such an atom through the blind forces of nature would be utterly minuscule." And there's many other quotes just like that from Sir Fred Hoyle. And again, I gotta emphasize, he was very much an anti-theist his whole life.
I remember listening years ago to Stephen Hawking's lectures. They published a set of, at the time, cassettes of his lectures in Cambridge that were, somewhat accessible to lay people. I mean, it's Stephen Hawking after all, but no, they were really good. And I remember in there at one point he talks about, and he uses terms like he doesn't use the term maybe miracle, but he says that, we are so lucky that at this point in the universe, this happened. And if this hadn't happened, there'd be no hydrogen. But he, of course, was also an atheist. And so there's a real discomfort with the idea. And I think for scientists in general, one thing that's come through in our discussions is that the concept of singularities, they kind of mitigate against science in a sense, right? Because science is built on the idea of regularity in nature and laws that are always functioning and so on.
And just so I'm clear,
go ahead.
I was just going to say, and just so I'm clear, and the listeners as well, singularities, are you referring to a black hole, or are you meaning a singular event?
Yeah, well, and maybe they're related, but yes, like the Big Bang would be a singularity, and black holes, events that don't seem to have a pattern of ongoing, they're not an ongoing law of nature in a sense, right? They're just a kind of a one-off, and how do you explain that scientifically? That's right. A problem,
Yeah.
and I think fine-tuning definitely fits into that category. The conundrum of these constants of nature, but we don't get them from anywhere. They just are,
Right.
And that's frustrating scientifically, because scientifically you want to derive them from something, right? And what do you do with that? And that's kind of what we've been talking to people about, is what do you do with that? And theists have their ideas, and atheists and agnostics have their ideas of what you do about it. And both seem to be able to accommodate it within their worldview, which is interesting to me.
Yeah, totally. Everyone brings their own worldviews to a set of data. Yeah. So to be honest, to the integrity of my own faith, given how compelling this idea of fine-tuning seems to be for so many people, even atheists, I wanted to finally put this one to the test as well. And to those who question why I do this, why do I keep on trying to prove or disprove what I believe, and I do hear that a lot, I do get that, I can quote many Bible passages that tell us to do just that, to do our homework and test our beliefs, find out and be convinced why we hold on to some idea that people tell us we have to believe. I've always been like that. I think that's why I was drawn to a career in science in the first place.
Yeah, absolutely. And like you mentioned, there's lots of good biblical evidence for the appropriateness of that, right?
Yeah.
I mean, there's the whole Bible in many respects is all about our struggle to understand, on the one hand, God, and on the other hand, this world that we live in, that we inhabit,
and on the third hand, ourselves.
And yeah, well, yeah,
Yeah.
absolutely. Yeah.
But all that being said, I was a bit concerned that listeners might not want another deep dive into some kind of a scientific topic. And I wondered if this idea of fine-tuning was so cliche and apologetic that is so much been there, done that, like doing an episode on the legitimacy of the Shroud of Turin or whether carbon-14 dating is reliable, things like that. I just don't want to do low-hanging fruit like that. And I didn't know if this one, fine-tuning, was another one of those. So I polled our private Facebook discussion group to see if they agreed that this was a good topic to do. And we got a big green light. 71% said absolutely yes, only 2% said absolutely no. And another 24% said that it wasn't so much an issue for them, but they can see how it is for other listeners. So Scott, that's a pretty big green light, don't you think?
Yeah, for sure.
So we launched in. We got quite a few comments and suggestions for what to cover with our guests, and we'll read out some of those at various times in today's episode. But first, let's talk a bit about the strategy that Scott and I want to take in this deep dive. We want to get properly trained experts for this deep dive, people who actually bring expertise and experience and actually have training in the relevant science. But we've learned from past experience that that means two things. We want to make sure we get the right expert to talk to, because even experts have a worldview. We were just talking about that, a unique perspective on things. And secondly, we're going to need to get our listeners ready to latch on to the big ideas that our guests casually launch into the air. So Scott, you and I need to set the stage so that we don't lose too much time with our guests, our experts, talking about simple definitions and analogies.
For sure. Yeah. What are we talking about when we're talking about fine-tuning? And frankly, as you and I have looked into this, that's been quite enlightening for me because I had only ever seen fine-tuning from kind of one perspective and came to the realization that even fine-tuning can be fine-tuned. Our understanding of it. Yeah.
So let's talk about that, because that is one of the things that I did want to clarify with our listeners before we listen to our experts next week. There are at least two different levels, I think at least three levels on this question of fine-tuning. One is the fine-tuning needed to produce the universe itself, the stars and the planets, that sort of thing. And then there's the fine-tuning needed to produce life. And for reasons that I'll explain in just a minute, I find that many of the examples people claim for fine-tuning to produce life, I find those examples to be really quite unconvincing. And because I only saw us doing one episode on this question, I mentioned to the Facebook discussion group that I didn't really want to get mired in that second aspect of fine-tuning, talking about the fine-tuning for life. And I got a little bit of pushback on that point. Here's one comment from Adam. He said, how would the fine-tuning argument even be an argument if it wasn't an argument for fine-tuning for life? Otherwise, you're just arguing that the universe is fine-tuned to exist as it is. Well, Adam, you're right, and I'm going to explain exactly that in a minute. We do need to distinguish the two, but first, here's another comment from Merv. Scott, why don't you read out Merv's comment?
Sure. So Merv writes, I'm curious what the statistical odds are for a life-sustaining planet like ours. That is, the right size sun, the right distance from it, a moon that influenced ocean currents, a tilt that gives us seasons, atmosphere that doesn't kill us yet, all the Goldilocks features that make our planet suitable for life. And given those odds, how many other life-supporting planets could we have in the Milky Way, and how many in the known universe?
And these are some of the things that, what Merv wrote there, these are some of the things that I'm talking about. Here's why I'm not convinced by those fine-tuning arguments related to life. I'm a biologist, and I know that life can exist under an incredibly wide range of conditions. Scott, what do you think is the upper limit for supporting life when it comes to temperature?
Well, sure. I would have thought, I don't know, something less than boiling, like something maybe 140 degrees or something like that. Fahrenheit.
And you're saying that 150 Fahrenheit. Okay, that's about 2/3 of the way to boiling point of water.
Yeah, I
So,
guess.
so in
Yeah.
Celsius, you're thinking 60 or 70 was the upper limit.
Yeah. Yeah.
Well, here's the thing. I want to get at the idea that life is incredibly resilient. One of the leading theories about where life first came into existence is deep in the ocean where superheated water is escaping from deep inside Earth's core. These things are called deep ocean hydrothermal vents or black smokers. The water coming out of them is dark, so they just look like they're smoking. Scott, any idea what the temperature and pressure are around those black smokers? Just take a guess.
No idea, really. I'm sure. Very odd.
Give me a number.
Oh, okay. So I don't know, maybe in Celsius, maybe a couple hundred degrees Celsius or something.
Try again.
Lower?
And higher.
300 degrees.
And higher.
No, really? 400?
Over
Higher?
400, no, over 400 degrees Celsius. And for the rest of us,
Wow.
that's 750 degrees Fahrenheit. That hot water that's coming out of them can be highly acidic, with pHs as low as stomach acid, which, in case it needs to be said, that's acidic enough to dissolve the steak and veggies that you've just had for dinner. Some of those thermal vents have absolutely no oxygen present and no sunlight whatsoever. All of this at depths and pressures that would crush any man-made submarine. And here's the thing, scientists have good reason to believe this is where life first began, at those temperatures and pressures and no oxygen and no light whatsoever.
So let me ask if they actually found life. You're these facts?
They do. Actually, yeah.
Oh.
You'll see pictures of these beautiful pictures. Just Google
Really?
it or YouTube it and you'll find, yes.
Okay.
Now, on the other hand, many forms of life grow happily in Arctic and Antarctic waters where the temperature is at the freezing point of water, sometimes even a little bit lower than the freezing point of pure water. Military scientists have discovered algae growing inside the fuel tanks of jet engines where there's no light, no water, no minerals. NASA have shown that microscopic bugs called tardigrades and a desert moss, this was very recently, a desert moss can survive the extreme cold and vacuum of space and highly radioactive environments. Scientists have found forms of life on Earth that are based on arsenic instead of phosphates. They propose that instead of life forms based on water, carbon, and oxygen, as we know here on Earth, they're thinking it's possible for life to be based on silicon and ammonia. They've looked for evidence of life forms on the moon, on Mars, and on meteors that travel through light years of interstellar space and then burned up in Earth's atmosphere. And the point here is not whether they found any such life on those things. They didn't. But instead that they thought it was possible, that life might be so indestructible that it might even be possible to find those things on those, space rocks. The bottom line is that life can exist. It can even flourish under a wide range of temperatures and pressures, pHs and chemical soups, and exposure to destructive things like radiation. So to talk about any degree of, quote, fine tuning to produce and maintain life, I think that's actually a pretty low bar.
Right.
Scott, do you remember the iconic line that Jeff Goldblum delivered in the first Jurassic Park movie?
I was about to mention it because as you were talking, that's exactly what I was thinking of. If I remember it right, life will find a way.
Life finds a way. Exactly.
Yeah.
Anyone who really wants to talk about evidence for fine-tuning of the universe for life has to recognize if what they're really pointing at is how finely tuned life is for the universe, or at least for the conditions that the life is growing in. Let me say that again in case the distinction wasn't clear enough. It's not whether the universe is finely tuned for life, but whether life is finely tuned for the universe, or the environment it's growing in. So I'll give you a couple examples of what I'm talking about here. I've heard creationists remark about the wonderful fact that the sun, Earth's sun, produces the exact wavelengths of light that is optimal for plant growth. Those creationists don't understand that the plants evolved the proteins that were specifically tuned to the wavelengths of the light that the sun produces.
Well, this is the whole Darwinian thesis. They're getting it backwards, right?
Yes.
Which is, in fairness, very understandable. When you look at nature, it's very easy to look at nature and say, "Wow, that's just incredible that the conditions were just right for this or that," instead of realizing that no, the conditions were there, and life adapted to those conditions.
Exactly.
Yeah.
Now here's another example. Tell me what you think about this one. Earth's atmosphere has so much oxygen in it, which is perfect for the life forms we see all around us. But the fact is, oxygen is dangerous in biology for the exact same reason that it's dangerous in chemistry and for people who choose to smoke their cigarettes around a tank flowing with oxygen. Scott, do you remember what happened to the first Apollo space crew?
Oh boy, yeah, I sure do. Yeah, the capsule, they got there was a spark, I believe, in the cabin, an electrical spark, and because the thing was so oxygen rich, it just it didn't explode outwardly, but it basically the fire just spread so quickly, and they couldn't get out, and so
Right.
they were burned alive. It was a terrible tragedy.
Yeah. Now, when I looked into it, it turned out they do want to say that they didn't die from burns. They died from lack of oxygen.
Okay.
All the oxygen.
Yeah.
Which you'd think this was a great idea. The people who built these rockets thought, okay, we need oxygen. We're sending them out into space. We're going to just, get all these tanks of oxygen, pure oxygen.
Yeah.
But that environment was just so combustible.
Yeah.
And you're right. It was just a tiny little spark that just started things burning, So the guys who died, Virgil Grissom, Edward White, and Roger Chaffee. Oxygen reacts with things and causes fires. It causes your apple slices to turn brown. It causes your bottled wines to go sour. Plastics to get brittle. The Eiffel Tower and your car to rust. This is all related to oxygen. It's a very dangerous molecule. And for millions of years, when life first formed on Earth, there was almost no oxygen in the atmosphere, until blue-green algae learned how to use sunlight to split water and produce tons and tons of oxygen as a waste product, which at first was toxic for living organisms until they adapted to become able to use the power of oxygen. Anthropologists like to talk about how amazing it was when primitive humans first learned how to use fire, but biologists will tell you single cells learned how to use fire billions of years before primitive humans.
Wow. Now, what about the anaerobic bacteria that actually don't use oxygen and produce methane, I believe?
Yeah, so they do thrive very well without oxygen. They were one of the earliest life forms. How they tolerate...
So there's another example, right? There's another example of that adaptation.
Yes, yeah. One of the earliest ones,
that life will make use of whatever it can to...
Yes. And so these are examples that are not arguments for fine-tuning of the universe for life. They're really examples of fine-tuning of life for the universe they find themselves in. And this includes a lot of arguments like the distance between Earth and Sun, Earth's orbit, the tilt of the axis, the presence of the moon and the influence it has on us, the presence of Jupiter and Saturn I've heard mentioned, the relative levels of carbon or water or some other chemical component of Earth, and again, the sun producing certain wavelengths that are optimal. There's so many of these, but I just don't see them as arguments for fine-tuning of the universe for life. They're really examples of fine-tuning of life for the universe they find themselves in, or at least for the conditions that the life is growing in.
Right.
But given the pushback people want to hear about this, I think our deep dive will include a closer look at the fine-tuning needed to produce life. But let me be clear, we're going to talk about the conditions needed not to support life, but to produce life. And there is a difference there. We will talk about the fine-tuning of the universe to be capable of producing the building blocks of life, the atoms of carbon and oxygen, and even metals like iron and copper, but not about the fine-tuning needed to support life, which again, these are not examples of fine-tuning for the universe for life, but arguments for fine-tuning of life for the universe. You're going to get tired of me saying that. But, listeners, there's a price to pay for us adding that to the material we're going to cover. Instead of one episode on fine-tuning, there's actually going to be 3. More on that later.
Well, it's like so many things, when you get into it, you realize that you need to press forward. One of the things we try to offer, I think, in the podcast, and really you try to offer, is more in-depth discussions and not just skirt the surface of these things, but dive a little bit deeper. Because there's lots of great stuff out there if you just want a primer on these issues, right? But take it a bit to another level, which is, for me, selfishly educational. Even if our listeners didn't get anything out of it, I would still. So there's a real selfish aspect to it. But anyway.
Well, you can also, you, the listener, can also take the time to get a book on fine-tuning. And there are great books about it, and it may take a couple of weeks to go through it. Or you can listen to 4 episodes. That's 4 hours. And I think we're going to cover a lot of the important material. So
yeah, for sure.
So whether we're talking about the fine-tuning of the universe to produce itself turn all those quarks and bosons and strings into planets and stars, or about the fine-tuning of the universe to make the building blocks for life. Again, the carbon and oxygen and metals like the iron in our blood. Either way, we're talking about the fundamental laws and physical constants that describe the universe. Well, really the cosmic egg that produced the Big Bang. Those laws and constants determine a lot about the bits and pieces that make up our universe. I think everyone knows what stuff is made up of, right, Scott?
Yeah, I think so.
Tell us, what is stuff made of?
Well, I mean, I think most people would say it's made up of atoms.
Then what are atoms made of?
Electrons and a nucleus, which is made up of protons and neutrons. And now they've determined that, I believe the protons and neutrons are made up of quarks. So it's turtles all the way down.
Exactly. So many fundamental particles.
Yeah.
And we don't need to worry about the names, but just to be aware of the point I'm making here, that just like the stuff all around you is made up of molecules, which in turn are made up of electrons, protons, and neutrons, even those electrons, protons, and neutrons are made up of even smaller bits. But what you should know is that there's atomic forces that hold all those bits and pieces together. And again, without getting into really heavy-duty detail, a few of those forces include a strong nuclear force, a weak nuclear force, and the electromagnetic force. There's lots of others, but we're going to just work with those three. Those three forces do different things. The weak nuclear force holds those subatomic particles together, the neutrinos and quarks and things. That's the weak nuclear force. The strong nuclear force holds together the protons and neutrons in the nucleus. And the electromagnetic force keeps the electrons attached to the nucleus. So I don't think that's too hard, right, Scott?
Nope, I think that's manageable, for me at least.
Can you parrot that back to me, or is that...
Oh, yeah, so the basic forces of nature, the strong and weak nuclear forces within atoms themselves, and then the electromagnetic force. And of course, the one you didn't mention, but the other force, key for, is the gravity, which is a really intriguing one. And there are some who would say it's not even actually a force. So that's
really?
when you throw, no, definitely. They would say that it's more a consequence, but it's not actually a force in itself. The old, maybe many of us have seen the analogy. It was very helpful to me of a rubber mat, and you put a ball on the rubber mat and it indents the mat. And then if you put a smaller ball on the same, right? So gravity is the mat, right?
Yeah.
So it's not really, which is what threw Newton off, because really Einstein, how could gravity exist instantaneously in all places?
Right.
Because if it's a force, it should have to travel, right? There should be a time element. I'm not a physicist, but these are some of the things that I've read about. Yeah. Right. So one of the things that this little, dive that we've been doing has made me realize, if I didn't before, is just how strange the universe is, and how we kind of live in a puzzle, and physicists are the ones trying to figure out the puzzle,
Right.
And frankly, I think for people like myself, at least, we'll only ever achieve a certain grasp of it. Yeah, and we'll have to rely on other experts for the details.
Okay.
Yeah.
So that's just getting our toes in the water. We haven't talked about a lot of other complicated things, electric charge, nuclear spin, things like that, but we don't need to, at least not for now. What we have there is enough to talk about this fine-tuning of the universe, and more specifically the forces, the constants that you're going to hear a lot about from our experts. And all of that is needed to produce, now, sorry, I'm going to get really technical here, but these are all needed to produce something that they call usable stuff.
Right. Yep.
Basically atoms or planets and stars, all usable stuff.
Yeah.
Everyone's heard that the leading idea on how the universe came to be is through the Big Bang, and we all have a mental image of what that looks like, even though that mental image is probably all wrong. I'm sure everyone listening to this is imagining a small speck that suddenly explodes and produces massive chunks and debris and flying out in all directions in what we call the universe. But if you want to be more precise, it wasn't a loud and violent explosion at all. Instead, it was an instantaneous expansion of time and space and the release of a lot of energy into that vacuum of empty space. And we all know that sound doesn't propagate in vacuums, so it was not a big bang, it was a silent expansion.
Yeah. Yeah, I never really thought through that, but yeah, you're right. There wouldn't have been any sound at all.
Yeah, and it wasn't an explosion with chunks and pieces going out. It
Yeah,
was it was an expansion of light, of energy
of
going into
energy,
the,
right?
yeah.
Yeah, and that's where, of course, we have that famous E equals mc squared, that energy and mass are equivalent. That one
Yeah.
can be turned into the other, right? So that energy eventually does become mass. But
Ma
but
Matter
go
is a
ahead.
frozen form of energy.
Yeah, yeah. That just blows my mind when you really think about that.
Yeah.
And
So here's what I want the listeners then to get in their mind, a picture. In the Big Bang, the energy began, you have this sudden expansion of time and space and all this energy being thrown out there. And the energy began to cool and condense into those subatomic particles through forces like I just mentioned, the weak nuclear force, holding together those neutrinos and quarks. And then forces like the strong nuclear force beginning to pull those together into bits and pieces called atoms. And then other forces, including the electrostatic ones that we explained in episode number 101. Scott, you'll remember that one about the proteins.
yep,
Now you've got these electrostatic forces pulling together the atoms, electrons, and neutrons, pulling them together into molecules. And then gravity pulling the molecules together into gas clouds, which compacted further into chunks. And those then collected in the form of planets and stars and solar systems. And you get the idea. It's all this
yep,
energy coalescing and crystallizing into the form of usable stuff.
yeah,
But here's where fine tuning comes in. If the relative constants of those forces are a little off in either direction, you don't end up with molecules and planets and stars. You either end up with an ever-expanding cloud of particles that never pulls together, or you end up with everything, and I mean everything, clumping together into one gigantic singularity, one big black hole. And apparently, we'll hear this from our guests, the balance between those forces has to be so precisely tuned to within a minuscule degree. I'm not going to quote all the zeros, to within hundreds of decimal places. The analogy that's so often used is like balancing a pencil on the sharpened end of its tip. In theory, it should be possible, but everyone knows that you can't balance the pencil on its tip. Even microscopic air currents are enough to knock it over. A little bit of an imbalance in those atomic and subatomic forces, the pencil falls to one side, you just get an ever-expanding cloud of gas. Or a little imbalance of those forces on the other direction, the pencil falls to the other side, and you get a super dense, hyper-compacted black hole. But if the balance is just right, within a razor's edge of degree of precision, and this is where it gets really interesting for me, then you end up with the equivalent of the metaphorical pencil standing balanced upright on its sharpened tip. In other words, you get a universe full of protons, electrons, and neutrons, and planets orbiting stars and galaxies. That's the fine tuning.
right. So if you walked into a room and saw a pencil balanced on its tip, what would you probably think, right? What would
Crazy glue.
Yeah, right. Yeah. In other words, you'd think it's jerry-rigged in some way,
Exactly. Yeah.
because randomly that's never going to happen.
Right.
You could sit there with a pencil and do that a trillion times, and
Yeah.
that pencil still would fall over. But in theory, one of those multi-trillion times, it could, in fact, stand on its point. So if it's standing on its point, you're kind of led to the idea that there's some tinkering here.
Exactly.
Somebody has messed, has done something.
And that's what Sir Fred Hoyle said, right? A super intellect
right,
monkeying with the physics. That's what he said, and he was an ardent anti-theist.
Yes, yeah. But honest enough that he wasn't afraid to say that, right? And this is one of the questions that we will be talking to our dialogue partners with, is that if the pencil is standing up like that, then what does that then mean? For some, they would say, well, that means there's a God, but that's not necessarily the only way to look at that, right? I mean,
Right.
one popular notion, and it's popular today, is taken fairly seriously by some very intellectual people, is that we live in a computer simulation, because
Yep.
this is so fine-tuned that maybe somebody's running a computer and we're just in this computer simulation, right?
Yeah.
So you can tell by that it's an issue they take pretty seriously. Yeah.
Okay, Scott, it's time for another comment from one of our listeners. Why don't you read the one that Christine sent us?
Sure. So Christine writes, often I hear apologists argue that the fine-tuning of the universe is evidence for God, but then they argue that God must miraculously intervene in living organisms to create the diversity we see. these seem like contradictory approaches to me. Why can't biology/evolution be fine-tuned and evidence for God too? I also feel like apologists exaggerate the fine-tuning argument beyond what it can tell us. What are realistic claims we can make from fine-tuning ideas? I would like to hear how the uncertainty principle, in other words, quantum physics, bounds the fine-tuning argument. Very good questions.
Yeah. There's actually several ideas in that question that I want to address. The first, the part asking about whether biology evolution can be fine-tuned and evidence for God too. My response is I think that's exactly what we heard from Dr. Chris Berger more than once. He came on 4 years ago, exactly 4 years ago from when this episode was recorded. We talked to him 4 years ago on July 16th. This is when Scott and I are doing this episode. He came on in episode number 30 and told us about emergent creationism. His idea that God rolled up a long list of ingredients into the primordial cosmic egg. And we talked about thermodynamics, about entropy, quantum mechanics, randomness, probability, order, predictability, determinism, massively large numbers, dynamic complexity, and chaos theory, and of course, neo-Darwinian evolution. And all of that being front-end loaded to create agape-capable beings like ourselves. That was episode number 30. But then he came on again 2 months ago in episode number 156 and talked about the cognitive machinery and wiring in our heads which evolved through the process of Darwinian evolution with the intent to point humans to an awareness of himself. So if you want more on that, check out Dr. Chris Berger's work on those two episodes, number 30 and number 156. What do you think, Scott?
Yeah, definitely. We had some really interesting discussions with him on those issues. And I think that these episodes that are coming up fit really well with them and reinforce some of the things. So that would be a very good thing to do even before listening to the new episodes if you have the opportunity.
Right. Now, I said there were several ideas in there that I wanted to respond to. There was a second part of Christine's comment. She said that she felt like apologists exaggerate the fine-tuning argument beyond what it can tell us. And then she asked, what are the realistic claims we can make from fine-tuning ideas? I'd agree with you, Christine. Some apologists do exaggerate the fine-tuning argument, or at least they misrepresent it.
Yeah.
Again, we've already mentioned today how claims like the ones that involve the relative positions and orbits of Earth, the Moon, the Sun, Jupiter, Saturn, for me at least, those are not fine-tuning arguments of the solar system for life on Earth, but rather fine-tuning of the life for the universe it finds itself in. As for any claim that has to do with fundamental laws and constants that determine the universe itself and its ability to make the building blocks for life, again, carbon, oxygen, etc., those apologetic claims don't seem to be exaggerated because even completely atheistic astrophysicists like the guest we'll bring on in 3 weeks, or like Sir Fred Hoyle, they will admit that minuscule changes in those constants and the physical laws could completely change whether you have an ever-expanding cloud of gas or a gigantic singularity black hole or the ability to produce oxygen and carbon. They'll admit that. They're just not going to ascribe any theistic cause to that whole story.
Yeah, so I think that Christine raises a really good point here, that sometimes people who are in the world of apologetics are obviously very much vulnerable to confirmation bias, right? So if something comes along that seems to strengthen the argument, and especially when it's scientific and when it's agreed to, like you saying, Luke, that it's not the scientists are denying these things. It's not the scientists are saying, well, no, these constants don't exist, and there's argument about that. No, that part is crystal clear. Everybody's agreed on the facts.
Yep.
Those, the question then is, what does that mean? And that's where, to Christine's point, that some theists will take that to mean a lot more than maybe it does, or certainly take it in a direction that doesn't necessarily have to be taken in. And we're going to hear from our discussion partners on that very issue.
Please indulge me for a moment while I pitch a proposal to you, the audience. If you're enjoying these episodes, and the fact that you're this far into the episode suggests to me that you do, then I'd like to ask for something in return. No, not your money, but your support nonetheless. What we ask is that you help our podcast by leaving likes and comments at our Facebook pages and website to increase traffic to our site. And even better, share this with one or more of your friends who you know are also wrestling with faith issues and their evangelical roots. Such a small effort on your part could easily double our audience. I hope you agree that this is worth promoting. And now, back to the episode. Right. Now, I think I hear something else in Christine's question. When she asks about apologists exaggerating the fine-tuning argument, I wonder if she's getting at how they point at the numbers, the constants and the equations, the physical laws, and they'll say that the numbers demand an explanation. They scream out design.
Oh.
The problem is that most of us can't get inside the head of an astrophysicist and see how they get so agitated when they see a certain number or equation. Kind of like a parent who just doesn't understand how the kids get so animated over a certain pop star or an influencer. But I thought of an analogy that will help the listeners, maybe, understand why astrophysicists get this way about the numbers. I'm going to do an experiment with you, Scott.
Okay.
And before we do, we'll first confirm to the listeners that I have not prepared you for this. You have no idea what I'm going to do.
No, I absolutely.
Okay, here we go.
No sleight of hand.
Scott, how many millimeters are in a meter?
How many millimeters? 1,000. So
How many in a centimeter?
10.
How many centimeters in a meter?
100.
How many meters in a kilometer?
1,000.
How many milliliters in a liter?
1,000.
What's the boiling point of water?
Oh, 100 Celsius. Yeah.
What's the freezing point of water?
0.
How many milligrams in a gram?
How many? That one might throw me off. 1,000. Is it?
How many grams in a kilogram?
1,000.
Okay, so lots
Wow.
of zeros and tens and hundreds there. You did perfectly, by the way, Scott.
Oh, wow.
In more ways than one, because you got the answers right, but you're making my point. In all those units of measurement, you'd say that it's all really boring. There's just a lot of tens, hundreds, and thousands.
Yeah.
It just flows out of a very simple logic, and it doesn't scream anything in particular to you. It doesn't scream design or manipulation, intentional intervention, right?
No.
Okay, here's the second experiment.
Okay.
Now we're going to do the same things. We're going to use empirical units,
Okay.
British units.
Okay.
Okay, so here we go.
I'm not gonna do well on this.
How many inches in a foot?
12.
How many feet in a yard?
3.
How many yards in a mile? 1,760. How many feet
Okay.
in a mile?
Oh, I used to know this. 5,000 and something, right?
5,280. What's the boiling point of water?
212.
What's the freezing point of water?
32.
How many ounces in a pound?
Oh, how many ounces? Is it 16?
How many pounds in a stone? In one
Oh.
stone? You know, when the British say he's
Yeah.
2 stones.
Yeah, no idea.
14. How many pounds in a ton?
No idea.
2,000. How many teaspoons in a tablespoon?
Oh, I should have known that. Yes. How many? What?
How many teaspoons in a tablespoon?
Oh, 4?
3. How many tablespoons in a cup?
4?
16.
16.
How many cups in a quart?
I don't bake. How many cups in a quart? How many cups in a quart? Oh, 10. I don't
4.
know.
4.
4.
Okay.
Yeah.
I'll let you off the hook now. I could go on, but I think you and the listeners will get the point. When you hear those numbers, they're not elegant or simple. They don't flow out of any kind of a logic. Instead, that system of measurements looks completely designed, right?
Yeah, arbitrary.
And I know that the metric system is also designed, but it doesn't scream design. It's just boring and logical, but the empirical system of measurements just screams design and manipulation. Clearly, there's someone behind those numbers. I remember even as a kid in grade school learning those units of measurements, I remember saying, who came up with these crazy numbers?
That's true.
Just a kid in grade school, and I'm already sensing there's some kind of design, a who behind these numbers.
Yeah.
It just sounds completely contrived when you hear those numbers.
Right.
And then you find out the reason behind those measurements, and you find they are contrived.
Right.
An inch, do you know where we get the inch?
I don't know.
Length of the king's thumb. I meant to say the width of the king's thumb.
Really?
The length of the foot being the length of the king's foot.
Right.
A
Okay.
yard being the length of King Henry I's arm. So stupid reasons. But again, the point I'm making is that these numbers scream design and manipulation when you hear them, when you encounter them for the first time especially. And that's what happens in the heads of astrophysicists when they hear some of the values of the universal constants. The nature of the number, you'll have to hear it from their own mouths. Those numbers just look and sound to them like they're manipulated and designed. And again, I think I've said this 4 times now, remember what the ardent atheist Sir Fred Hoyle said about some super intellect monkeying around with the numbers that control the formation of the carbon atoms.
Yeah. No, that was good. That's a good analogy. The other interesting thing about those numbers is that, I mean, the great thing about the metric system, of course, is that the numbers can all be derived from each other. They're all related, right? So right. 10 and this, you're right. But in the British system, there's no relation between those numbers. You can't get one number from another. To some extent, in some cases you can.
Yes, yeah.
In many cases you can't, right?
Yeah.
And one of the things about these constants is that they're not the result of some equation. They're not something that we come to from something prior. They just are.
Right.
Yeah.
We're going to hear that several times from our guests. So let's talk about a guest. We're near the end here today. We want to give you a sneak peek into what we've got lined up for you. What kind of expertise do we have for you? We definitely wanted to talk to someone with expertise in a relevant scientific discipline. So I'm thinking astronomy or astrophysics, for example, and someone who's promoting the kind of fine-tuning rhetoric that Christians are listening to. Because again, that's the purpose of this episode. We want to take a deep dive into fine-tuning as a rationale for holding Christian faith. And so I want to talk to somebody who knows what they're talking about, who's doing exactly that. And for that, we have Dr. Luke Barnes, an astronomer and cosmologist at Western Sydney University, who puts a fairly heavy emphasis on fine-tuning of the universe for the appearance of life. We also found someone, a pair actually, Dr. Ellie Fetter with a PhD in mathematics and Aaron Zimmer with training in physics, as well as some maths and philosophy, both of them also having rabbinical training, they're the hosts of a new podcast called Physics to God. They take an incredibly deep dive into the mathematics and physics behind fine-tuning with a particular emphasis on the fine-tuning needed to produce a universe and not necessarily life. So complementary to what we're going to hear from Dr. Luke Barnes. And remember, I see those as 2 very different questions, fine-tuning for life versus fine-tuning for the universe. And the other thing that's worth mentioning is all 3 of these, 2 episodes, all 3 of them come to this with a theistic worldview. Of course, Luke Barnes would be a Christian theistic view, and Aaron and Ellie are coming at this with a Jewish theistic worldview. We also wanted to talk to an expert who's not a theist, but who nonetheless sees evidence of fine-tuning, who will tell us about fine-tuning without a tuner. And that's going to be Dr. Geraint Lewis, professor of astrophysics and the head of the gravitational astrophysics group at the University of Sydney, Australia. So, Scott, how's that for getting the big guns for this topic?
Yeah, it's impressive. It's very impressive. It's a real privilege to be able to talk to such smart people.
Yeah, you enjoyed those talks.
Oh, yeah, just absolutely.
The listeners are in for a treat.
I think so. Yeah. And I think hopefully we'll be very intrigued. I know for me, it's really intrigued me to, because each of them has referred to various books and articles and things like that. And it's really intrigued me to even continue, the journey kind of thing. And so it's been great.
So that's what we have in store for you the next 3 weeks. We're going to start next week with Aaron and Ellie. Again, Jewish perspective on this fine-tuning to produce the universe. And they've got a lot of maths and physics behind them. So, and a great little podcast. Yeah. Anything else you wanted to say, Scott, before we go?
No, I don't think so. I think we've covered it pretty well. So
okay.
Looking forward to hear what our listeners have to say.
Well, then before we go, I just want to say one last thing. Scott, happy birthday.
Oh, thank you. Yes, it's actually tomorrow, and I don't know if I'm looking forward to it or not, but it's going to happen one way or the other.
For you, it's tomorrow, and for the listeners, it was 2 days ago.
Yeah, right.
So, happy birthday.
There's a lot of time dilation in our podcast.
Yeah. Okay.
Thank you.
Thank you all for listening today. Tune in next week for Aaron and Ellie, and we're going to get this deep dive started. Bye for now.
Looking forward.
Thanks, Scott. Happy birthday.
Yeah, thank you. Talk to you later.
Bye now. You've been listening to Recovering Evangelicals with your hosts, Luke Jansen and Scott Dyer. Send your comments and suggestions for new episodes to lukejjansen@gmail.com. Join our private discussion group on Facebook by searching for the Recovering Evangelicals podcast group. Look for the logo that you always see at your favorite podcast catcher and ask to be let in. Subscribe to lukejjansen.wordpress.com if you want to get advanced releases and group posts, or browse through our archive for a full listing of all our previous episodes. And please help the podcast by sharing with a friend and leaving a review at your favorite podcast catcher.